Using the periodic nature of circular functions. So when we're looking at functions on the coordinate plane, in particular we're talking trig functions here, they have a rotational or circular nature to them. And we discovered that when we looked at coterminal angles. Also, when we dealt with linear and angular speed, we're talking about rotational or circular motion. And these trig functions have that same nature. In other words, we may be making more than one trip around the unit circle. And we're going to work a little bit with that here. And we'll see that these sine and cosine functions have circular natures, particularly with what we're getting ready to deal with coming up next, where we're going to be graphing sine and cosine functions. All right, well, let's see. We're asked to find the sine of 13 pi over 4. Well, first off, I see some 13 pi over 4 in particular. And so I know that basically my basic starting point from the unit circle is that cosine is going to be square root of 2 over 2. Sine is going to be square root of 2 over 2. I'm just not sure which one's positive or negative, depending on what quadrant we end up in. Now, so we got 13 pi over 4. And if we express 2 pi in terms of something over 4, that would be 8 pi over 4, right? So let's see, I could take 13 pi over 4 and subtract from it 8 pi over 4. That's 2 times around, right? Counterclockwise. And that would leave me with 5 pi over 4. So we're going counterclockwise, zip, zip, zip. There's 8 pi over 4. I got to find 5 pi over 4 again. And shazam, I see it right here. All right, now, so what is so we're in the third quadrant. And that means that tells me that both the sine and the cosine function are going to be negative. It's something pi over 4. And so the sine is going to be negative square root of 2 over 2. All right, let's see. Now I've got a cosine. Oh, I got a negative. I'm going clockwise this time, and we're going to end up at negative 4 pi over 3. And the negatives, I'll confess, are always a little bit trickier for me. I have to think about those a little bit harder than I do the positive. But let's see, if I express 2 pi in terms of something over 3, well, that would be 6 pi over 3, and I'm going to subtract from it 4 pi over 3, and I'm going to see where I end up. And so that would put me at 2 pi over 3. Now, once again, once I see a trig function is expressed as something pi over 3, well, I know that the sine function, cosine is going to be 1/2. I'm not sure if it's positive or negative because I got to figure out the quadrant. And the sine is going to be square root of 3 over 2. But let's see, I want to find 2 pi over 3. So okay, I came this way. We're going clockwise. Well, there's pi. That would be 3 pi over 3. I got one more pi to find. And we already discovered I really need to be looking for 2 pi over 3. And so there we are. And the cosine there is negative 1/2. Put me in the second quadrant. Of course, I know also that might help me along. All students take calculus. All right, we're going to look at another one on this periodic nature of circular functions. So this time I'm looking for 15 pi over 6. And again, I see something pi over 6. All right, well, that tells me what? That the cosine, whether it's positive or negative, is going to be square root of 3 over 2. And the sine, whether it's positive or negative, is going to be 1/2. And I'm trying to figure out, okay, how many trips around the sun or circle am I taking? Well, let's see. If I express 2 pi as something over 6, well, that would be 12 pi, right? 12 divided by 6 is 2 pi. So we take 15 pi over 6 minus 12 pi over 6, and that leaves us with 3 pi over 6, which then I can reduce down to pi over 2. Okay, pi over 2. Well, that's a quadrantal angle. Now, at a quadrantal angle, what's happening here? X is 0, or the cosine is 0, and the sine is 1. And the tangent we know, when we're talking about unit circle, is y over x. So if y is 1 and x is 0, once again, if I got a 0 in the denominator, what do I have? Well, here at 15 pi over 6, the tangent is undefined. How would you like to be undefined? That might actually not be a bad thing. Sometimes people define us in ways that they're not actually true. Oh, work with perseverance.